All right. All right. Welcome everyone to the March DocumentDB Insider Hour. I'm Doug Bonser, and with me today I've got Tim Callahan. And go ahead and you want to say hi, Tim?
Hey Doug, good to be here. It's been a while. I think it's been about a year since I've been on the Twitch show, so it's my anniversary.
All right. Sorry, I had some feedback there from another source, getting a delay. But sorry about that.
No worries. You had me nervous that I lost audio.
Okay, and I am still getting it. So this is very strange. No, you didn't lose audio. I'm getting double audio. Uh, uh, okay, I know where it's coming from. All right, sorry about that, everyone. My bad on my setup here. All right, so we're good. So, all right, yes, all right. Yep, like I said, been a little bit over a year. So welcome back to the show. And today we are going to be talking about operational capabilities of DocumentDB. All right, so a lot of times we talk, if you've tuning into this regularly, a lot of times we'll talk about specific features, dive into that. But really, we just wanted to, we thought it'd be good to take a step back. All right, and let's look at all of these really unique operational capabilities of DocumentDB, all right, and basically how these can help you. All right, so with that, I guess we'll jump right into it, Tim.
Sounds good. Yeah, like you mentioned, we oftentimes when we're on calls with customers or when we're traveling and we meet people at conferences and such, there's often two different audiences. There's the developers and the operation folks. And as we talk about DocumentDB features, capabilities, strengths, things it does that are rather unique given its architecture, we end up with conversations that are almost split. Like we'll pull out a deep dive deck, and we're talking to operations folks, and we skip 5 slides and show 2, and skip 1 and show 1, and the
Right,
inverse is true. Sometimes when we're talking to developers, they might yawn when we talk about backup or how snapshots work,
right,
because to them they just want to access a database. It's someone else's problem, right? That meme where the, the girl is in front of the building that's on fire, and it's ops problem now, or worked in test or something. So
right.
I'm with you. I wanted to kind of, as we pitched ideas to each other, it's 10 operational capabilities. Um, Not necessarily what I would say are the top 10.
Mhm.
But at the same time, I did a double skip on my slide. I picked 10 that I thought were really interesting and important and worth noting. And again, it's in no particular order of importance. So we're not doing a top 10 countdown and wait till the last one, because that's way more exciting or interesting than the other 9. So I felt,
Got it.
kind of putting it together like this makes a nice backdrop for a conversation like we're having here. And eventually we'll probably make this a little more of a productized deck that we can use when only speaking to operation folks,
Got it.
as part of a meeting or an immersion day.
Yeah. And for those of you who are listening, do stick around for all 10, even though they're not in any particular order of importance. Yeah, you're going to want to stick
there,
around for all of them.
there will be a quiz,
Yeah.
and Doug will provide the prize. I see. Is my mic picking up okay? Because my roommate Trisket, my dog, came in and laid out in front of me, so I did have to back up a little bit from my desk.
It's still good. Can hear you loud and clear.
Perfect. All right. So, first off, and this is an architectural slide that we use often in presentations. And it really is a fundamental capability of the system, right? So when DocumentDB was built, we looked at existing database technologies, how they're architected. Did the same with some other Amazon relational database services. And what we decided was, using this delineating between compute and storage, right? We have a deck that goes way deeper into kind of how this evolved.
Hmm.
But really what it speaks to is we've got a compute layer, and in the compute layer we've got instances, something running like on an EC2, for example. And those the compute instances bring with that their own set of resources. So how much RAM is in the compute instance, the amount of vCPU, Is it Graviton or is it Intel, or maybe there's a architecture number 3 in the future? How much network bandwidth the instance type is allotted? Local storage, right? In DocumentDB, we do need local storage for sorts. We need it for building indexes, which can require quite a bit of local storage.
Mhm.
So, and then with those instance sizes, there's more database type terms of resources, right? So a certain instance can support 1,000 connections, and double the instance size, you might get to 2,000 connections. The number of open cursors that an instance can support, and the number of transactions, live transactions that are running on a server. So, one thing we let customers decide is how big should my instances be, and that's going to be based on your performance characteristics, how much data you have, how large of a cache you want to meet your performance SLAs for your application. Beneath that is the storage layer, and by decoupling this, there's not kind of a forced. If I want more storage, I need a bigger instance, or if I have a bigger instance, I'm bringing along more storage that I may or may not need to use.
Right.
So down in the storage layer, it's super simplified, right? When I first started seeing these types of systems, and I came from an Oracle foundation early in the 90s. I remember as an Oracle DBA, I would run out of disk and I would get more disk and I would put it in my server, and then I'd create a file on that disk, and then I would tell Oracle that it has access to that file. Long gone are those days, right? What we do is we've got this storage volume that just simply grows dynamically. You create a DocDB cluster. We need a little bit of storage, so likely a 10 gigabyte chunk is what we would allocate for it. That's the smallest and the allocation unit. So as you grow beyond the 10 gig, we go to 20. When you need more, we go to 30. So these little chunks are distributed like that. And then as you delete data over time and you make room, the volume is smart enough to shrink, because you are paying for storage, right? So the more of these that you allocate, the more storage cost you'll assume with your DocDB cluster. The other thing I find interesting here is the storage performance, right? There's how much storage it gives you, and then there's the performance of the storage itself. It grows, and it's very dynamically scaling, and it's not tied to the size of the storage you're consuming, right? Some other databases, it might be for every terabyte of storage you're paying for, you might get 1,000 IOs per second. So if you want 10,000 IOs per second, and that's one way to serve it. So for 10,000 IOs per second, you'd need a 10 terabyte volume, which means kind of a coupling again, right? If you want more IO, you need to be paying for more storage that you don't necessarily need. Or you might be paying for more storage and getting more IO that you didn't need in the first place, and you feel like you're being billed for both. A measurement I can share here is on high-end benchmarks, let's say I'm inserting small documents as fast as I can with a single secondary index. You can push this storage. I've pushed it over 1.5 million write IOs per second. And that's definitely, very, very high-end bespoke SSD SAN territory, right? If you're buying those kinds of devices in your data center, those are really high-end devices on probably fiber connections, right? Like really high-end. But in DocDB, if you need it, you get it. And to get there, it wasn't about having a 32 terabyte storage volume, and therefore there's kind of this ability to spread out. This is at well less than a terabyte.
Right.
I was consuming in that type of test.
Yeah, and that's how do I say it? It's prior to coming to AWS, again, worked with databases like you, and yeah, like I said, these were a lot of things that you had to think about, and honestly, I still find myself falling into that same trap, right? Thinking about these, and then sounds kind of silly, but I realize, we don't have to worry about that because it's separated at auto scales, the storage and the IOPS scales, and and it's great for customers because now they don't have to think about this and try to figure out how much they have to provision up front. I mean, frankly, there's no way to pre-provision it. The service just takes care of it for you.
Mm-hmm. And it also, to your point about leaving your past behind sometimes, when you look at monitoring DocumentDB, IO performance is something I never look at. Like I don't ever look at the latency graphs
Mhm.
to storage, right? They are instrumented and you have availability. I find more than anything else, eventually, if you push it hard enough, you're going to run out of bandwidth between your DocDB cluster, between your compute and your storage. And that's an area where, right, to get to 1.5 million IOPS, I was on a 16XL because I needed 40 gigabit, right? There are certain, there are scientific laws of speed and sound and light that have to be looked into. But certainly
Right.
for the high end bespoke workloads, we can handle those. And then as you go smaller down, you're still going to get as much I/O as you ask for out of your the storage system itself.
Yeah, I mean, it's honestly it's a really cool, if I may say so. Architecture and this kind of like you were saying, this is one of the things I spend a lot of time explaining to customers because this separation is key to a lot of these other remaining 9 operational capabilities we're going to talk about here. So it is key to the architecture, and once you understand it, right, then you can appreciate how this really benefits the customer.
Mhm. And on the next slide, we're going to kind of talk about why on the slide we were looking at, right, we saw there's greens and yellows, right?
Hmm.
I just changed the slide. This is number 2. We're going to talk about high availability. The slide is the same. The conversation is different, but it's, architecturally, it's what we've built here that gets us to where we want to be. So when it comes to high availability, our goal here is to make sure you have as many nines as possible when you're running DocumentDB so that your workload can just keep going, right? Things fail, hardware fails.
Hmm.
So the instance you're running on might be in a rack that has an issue. It might be on a server that has an issue. So you want to position your availability goal, align that with how you deploy DocumentDB in production. And you can do lesser things in test and QA. You can run tests to make sure everything you're deploying works as advertised and to meet your needs. But the first thing to think about in high availability with DocumentDB is there's an instance in the middle that we call the primary, and then left and right of it in this slide you can see these replicas or read replicas, as we normally refer to them. Important to note here is that the primary does all the writes. It's a monolithic architecture, and we'll talk about what that means in a future operational slide. But one server is going to do all your writes. All 3 servers are there for reads, and you decide whether or not you're going to use the replicas for reads or just have them for high availability. When a write occurs in DocumentDB, our goal is to make 6 copies of that data across 3 AZs, 3 availability zones. So we're going to make 2 copies of your data in each of 3 availability zones. And in this picture, let's just say we only had a primary.
Hmm.
Um, Pulling that off without this sort of architecture is difficult, right? If I was running a database on EC2 with attached storage, I'm going to make 2 copies in my local AZ, but I'm going to need to actually have physical servers and a similar setup in the other AZs to make sure the data was durable beyond the primary server itself. And that's important for failover if something goes wrong. So when a write occurs, the primary does the work and it pushes those writes down to storage, cross AZ and in the local AZ. And as soon as the first 4 writes are acknowledged of the 6, it's going to declare the transaction durable, and it's going to return to the caller that with a big thumbs up, A-OK. I've performed the insert, the update, the delete. It might have been atomic. You might be in a transaction waiting for a commit, but when you're done, the caller gets a response back that everything is durable, and then the last 2 of 6, right? Because we only waited for 4 for performance and quorum, right? We want to make sure we have the majority of the writes acknowledging.
Right.
The last 2 occur asynchronously, so they still get done. It's just that the primary is not waiting around to let the caller know everything is done for those last 2. For people who are really into databases and quorum and things like that, what it comes down to is, our durability guarantee is that's what we favor. With Mongo APIs, with the driver, you can override that on MongoDB, for example.
Hmm.
In DocumentDB, we ignore write concern. So if you say write concern 1, meaning I only need it durable here, the right concern is ignored. It's going to make this durability guarantee regardless of what the client application says it wants. Um, and so for things like quorum, right? If I want to have a writable system, I need 4 copies of data. So if for some reason an availability zone fails completely, I still have 4 copies of my data across 2 AZs, and my cluster keeps going. For reads, we need at least 3 copies of your data. So if we lost a full AZ and we lost, and one of these storage nodes went down, and so you only had 3 copies of your data, at the moment it's fully readable. It becomes writable as soon as it self-heals. Right? So it'll detect that we're down to 3 copies, and in the AZ that only has 1, it'll make another copy. And as soon as we get back to 4, we get back to writable. But those are our guarantees for data durability. If a failure should occur, right, high availability is about the system being up and running.
Mm-hmm.
So let's say the primary is in a rack, and the server that is running on has complete failure, right? There's total redundancy within these servers, but there's always the possibility that there's failure on both components of something that's redundant. There's constant monitoring going on in the back end of these servers. We detect the primary stops responding. Immediately, an election occurs remotely, and we decide one of the 2 read replicas to be promoted to primary. That's an operation that takes about 30 seconds. And once we get a new primary up and running, your cluster is back to writable. And in the immediately following that failover, it'll rebuild another read replica to get you back to the 3. Right? You can deploy to DocDB as a single instance, 2 instances, all the way up to 16. You can have between 0 and 15 read replicas, but it'll get back to strength in about 8 to 10 minutes. That's about the time it takes to bring a new instance into a cluster. Some customers, right, dev and QA, perfectly fine to run with a single instance primary only. Mm-hmm. Don't really recommend that for production unless you're looking for extreme cost cutting. And the big thing there is you're willing to wait, right? If you have a failover with a read replica, 30 seconds, you're back to a writable cluster. If you have a failover and you only have a single instance cluster, then you're going to wait the 8 to 10 minutes that it takes to stand a new primary up and get back to work.
Right. Yeah. So, like I said, I mean, it's we don't recommend it, but it is an option. And I have talked to some customers that are using it because they're okay with 2 nines of availability for that particular use case. Yeah. So you do have that, and that the other interesting thing, because of the separation of storage and compute, that 8 to 10 minutes, right? That's pretty much constant, whether I've just got 10 gigabytes of data or the 128 terabytes of data in my cluster, right? Because the storage and computer are separated, I can add, remove instances, failover instances, and no data has to move, right? So that's another, in my mind, one of the best benefits to this architecture. A lot of these operations with other databases that take a long time, they take a long time because there's a lot of data to shuffle around. With DocumentDB, that's not the case.
Yep, and that's a preview for what's to come, because we are going to go deeper into read replicas in one of these top 10s down the road. So just hold that thought, and we'll go deeper when we get to read replicas. We could talk about our personal experiences with what you're describing as well. It's great to say, hey, just you want to read scale, just add more read replicas, but it might take 4 days, and you needed it 10 minutes ago. So by the time you get it, you might be over the rise in traffic to your website.
Exactly. Yeah. Sorry for jumping ahead.
No worries at all. That's your pay. That's the point of this, right? Is to kind of put it all out there, and we might want to reshuffle the slides at some point and kind of have them in an order that, A leads to B leads to C. But something really interesting here is cloning. So DocDB, we're talking about the architecture. We've got the compute layer. We've got the storage layer. SANs have supported snapshots and cloning for quite some time. We've got the feature natively implemented within DocumentDB. I think this feature came out mid last year, maybe late last year.
Yeah.
But it's super cool, right? Like in the picture, it kind of shows what's going on here, but we're going to keep using this running example. I've got a 3 instance cluster. So primary and two read replicas running on this distributed storage volume. And the challenge is, let's say, in the real world, my support department needs a copy of production because they need to troubleshoot a bug reported by a customer, or they're running a report and they're getting a number that looks incorrect, and development needs to dig in. But we don't want folks just attaching to production and running. It might be a long running query. It might hurt the performance of other things to be running it simultaneously. So you want a copy, right? Or dev or QA. QA is going to run the smoke test, and we want to run against real customer data as opposed to synthetic data. Mm-hmm. Prior to cloning, right, your options were good old, Mongo dump, Mongo restore. Let me Mongo dump my entire system. Mongo dump works just fine on DocumentDB. I'm going to write all my data to a file, and then I'm going to Mongo restore it into a new cluster. And that's super expensive, right? Mongo dump, full collection scan on every single collection, write it to disk. Mongo restore, I'm going to load the data. While I'm loading the data, I'm building indexes, right? This can be an extremely long process to get from A to B, to have that finished copy of whatever, it's a test database or a production database. Another option is, we'll talk about this in a future slide, backup and restore, right? DocumentDB performs streaming backups. You can use those streaming backups to source a new cluster through point-in-time recovery, which we're going to go deep into in a few slides. It takes time, right? Because for that, it is physically copying data, right? So better than Mongo dump, Mongo restore in that the data it's copying, when it's done copying, is done, right? The indexes are in there. The data is already loaded. It's just the bigger your data set, the longer your backup, the restore of the backup is going to take. It is going to be directly proportional to the size of the data. There's no way to avoid that. And then some customers, I've done this in the past, you write custom scripts to try to make a Mongo dump, Mongo restore type process faster, more concurrent than it would be otherwise. What cloning does is, again, it's a really cool feature. It's going to create a new DocumentDB cluster based on an existing running DocumentDB cluster, and I'll call it as of now, right? It's a point in time. So when you start the cloning process, it's going to provision your resources, your cluster, and then declare a point in time from which it is a perfect copy of production in this example. And production's unaware that this is happening, doesn't get slowed down, it doesn't get stopped temporarily. It's kind of, I looked at it as pointers. So the moment the copy is made, the clone is ready to go, and it has a perfect copy of production data. And a moment later, an insert hits production, and they've now diverged. And that's okay. That's the point of the clone, is we have our own copy in a fast, efficient manner. With these pointers, a great side effect of that is, one of the dimensions of DocumentDB cost is storage. So you need to pay for, we make 6 copies of your data. You only pay for one, but you do have to pay for that one. So if I have a cluster that has 30 terabytes worth of data, there's a cost to maintaining the 30 terabytes. The clone, the moment you create it, the size of that clone is actually 0, because it's just pointing to the existing production data. It's read only, so it, at that point, it hasn't touched any data yet. And then as you start doing things with the clone, inserts, updates, and deletes, for example, you're going to start diverging more and creating cost in that manner.
Right. Yes. So, and that's really cool. That's one of these, I feel like it's one of these features that are kind of, I don't want to say misunderstood, but maybe not appreciated as much for what it's really doing. I mean, there's a lot of really cool use cases for this, and the benefits, like you said. I mean, before this, yes, you could create a clone, and it's going to take some time by either Mongo dump and Mongo restore, or restoring a snapshot. But you're also paying for a full second copy of that data set. Right. In this case, if you're creating a clone that's read only, you're incurring no extra storage cost, right? There's some cost for the instances in your clone cluster. All right, but that's right. One of the neat aspects of this, and that the way it works, a little bit under the covers, like you're saying, that copy on write protocol, right? So the original or the clone can change this data, but with copy on write protocol, we'll create a new copy of that data that's accessible only by the cluster that made that new copy or that new update.
Mhm. And as you said, right, my career was founded on a pre-cloud world. So
Yeah,
I always have to push myself to think of uses for things like this. I'm not used to use it and throw it out, right? Even in my
yeah,
life, I recycle as much as I possibly can. So throwing things away is always hard for me. The other day, I was working with a customer. We needed to do a Mongo dump on an extremely large collection, and they were nervous that it might affect the performance of the running server. And I thought after the fact we could just clone it on a big primary
hmm
and run the Mongo dump from the clone. Right? It was a system that was idle. They shut off the upstream processing, and they wanted to get this done, and they had other things going on. So it was like an example of wow, cloning would have been a great opportunity for that, or end of the month batch jobs, right? It's a
hmm
reporting job. The month is over. We talk about on the slide we're showing here, right? One way to handle the batch job is put a 24XL into this 3-node 2XL and use that for your, to connect direct and use that for your reporting. But the downside to that is that 24XL is part of your read replicas,
yeah,
and it's going to start receiving traffic from your regular, right? It's not all or nothing. It doesn't exclusively belong to this batch reporting job. So
right.
great example, end of the month, 1st of April to run my March reports, clone production, 16XL to go fast with a big cache, run my reports. Maybe they take 10 minutes because it's exclusive and large, and then throw it away, right?
Mhm.
And what have I just spent my money on? I've got some IO, I've got 20 minutes of a 16XL, and I have zero impact on my production workload.
Yeah. Yeah, I mean, honestly, it is really cool, and it's I'm like you. All right, sometimes coming from that background, it's yeah, it's ingrained in my brain. Still trying to get out of that, but yeah, it's a very cool feature, and I talk to my customers a lot about it, and
Mhm.
the more we do, can find some really interesting use cases for this.
Agreed. Yeah, I think and on the last operational feature, cloning is a big part of our rate scale story, right? To kind of give you a teaser for when we get there. Uh,
Cool.
so next up is backup and recovery. Um, we talk about this to customers often in most of our slides, but what's important to note about how backups work in DocumentDB, this separation of compute and storage, and this storage is actually smart. It's not like distributed EBS volumes, block volumes. Like it is very aware of what's going on above it. And because of that, it can do smart things, right? One thing it can do very well is allows us to do these, we call them no impact backups. And by no impact, we mean while the writes are going to storage, storage is also aware that it needs to be recoverable and have backups and be able to go back in time for point in time recoveries. So while the writes are occurring to this storage volume, it's streaming the information it needs to have what we would consider a backup and to do a recovery from a past point in time to S3. Um, what that gets us is several things there. One thing it gets us by using S3 as a target, right? S3 is something we created a long time ago.
Mhm.
Um, S3 is extremely low cost and extremely high durability, right? The two best things you could imagine for your backups is to put them somewhere that they're cheap and that I think it's, quote me if I'm wrong, Doug, 11 nines
Yeah.
that we have for S3. And the other good news there is it's easy to get the data back, right? There's various tiers and things on S3. There's Glacier. There's ways to kind of put things there for a very long time and even reduce costs further, right? But standard S3, very understandable, right? If you look at your backup cost, it's going to be the S3 rate for the size of the backups. From a customer perspective, you make a choice when you start a DocDB cluster. You're going to decide, do you want to retain backups for, the dropdown is starting with 1 day minimum and a maximum of 35 days. Um, Many Amazon services for things, probably not backup, but they might have a zero option, right?
Mhm.
The minimum backup for us is 1 day. Um, Reason being is we want customers to be able to recover, and we give you that first day for free. So there's no reason to not have at least 1 day's backup of your DocDB cluster. But you can go up to 35 if you want to. And what's going into the backup is incremental. So from a backup perspective, even though in the UI you're picking a backup window, I think it's a 30-minute backup window.
Hmm.
What that's really driving is when data gets purged, right? Because the backup is streaming and it's not like a snapshot, it's not going in there making block copies of your data. It's always streaming to S3. When we hit that window at the 1 day mark, at that time, that's when we cut off for the day or day 2 or day 3 or day 4. And what you're paying for is the churn beyond that 1 day copy. So if you have a read mostly workload, your backups for 7 days versus your backup for 14 days is likely to be similar, right?
Yeah.
Not exactly the same, but you don't have to think of it as every day's backup is another X. And if I'm going to do 14 days, it's 14X versus 7 days is 7X. So you can run backups longer than you might otherwise, but you always going to start from your SLA to your customers, right? If you need to be able to recover up to a month, then you want to have a 30-day backup window in here to have that sort of retention. Um, the other important thing about backups is that's what we use for point-in-time recovery, which we're going to talk about soon. And we can point-in-time recover as far back as your oldest backup and as close as 5 minutes ago. So you can't do a point-in-time recovery as of 30 seconds ago. Haven't found a use case where that would be important, but it is worth noting, right? It's 5 minutes is the minimum point-in-time recovery back, and then up to the backup window itself.
Right. And the again, because of the separation of storage and compute, the coming from based on background before coming to AWS and working with other databases, and in this role, talking to customers about backups and their concerns about the impact to their production workload. Right. They've got constant workload 24/7, so there's not really a good time where they could run backups without affecting it. So then they look at standing up another instance just for that, and now that's extra cost, right, for the infrastructure for that instance, and possibly a license for the software, just to do a
Mhm.
backup on that node. All of those complexities is just taken away, and it's handled automatically. And the
Yeah.
other thing, one last thing I did want to point out, right? We do, you can select up to 35 days. So that's backups that the service will manage for you, but you can certainly take, and I apologize if we're getting ahead here again, Tim, right? But you can do manual snapshots. If you need to retain past 35 days, you can do that through a manual snapshot.
So this is pure coincidence, but see, Doug and I are like, we started on the same day. So I think we're in essence, sometimes
We
we're the
we
same.
think the same.
We're the same person, right? Snapshots is something I put in, I think, at the right point in this particular deck. But to follow up on that last comment, I in my past lives, having been a DBA, having done infrastructure, absolutely like MySQL, right? I might have an extra replica, I forget what the terminology is now. It's way more correct than I think it was back when I was working on MySQL. But you'd have that extra one for backups. And to Doug's point, if it's only sitting there for backups, it's not useful 23 hours a day. You might have it there for read scale to throw queries at, but then you turn off the reads while you're doing the backup, and you're just kind of going through all these gyrations. And what you want is to use the resource to its fullest. And the point here is whether you're running burstable instances or 24 XLs, the server is completely unaware that it's being backed up, and it doesn't need to know. The streaming backup goes down. The I/O for reads and writes goes up to the compute instances, and they're totally separated from each other. But Doug just touched on snapshots. So we've got this streaming backup, and I'm trying to, I turned that prior slide into something I think a little more obvious here. So let's say we have a server and we pick a 4-day backup retention. So in this box in the middle, let's pretend that's S3 to us, and time's going from left to right. As my backups start, it's streaming day 1. These boxes might be different based on how many writes you do that particular day. So with 4 days worth of backups, I've got, this line from left to right. I'm using about that much S3 space, right? This is totally back of the napkin, right? There's not a lot of science to show you here, but let's say that's what my backups look like. I'm taking up that much space. I'm paying for that much S3 storage. Doug just mentioned snapshots. So if I want to take a snapshot, it's a user initiated thing. You can do it via CLI, CDK. You can use the console, right? Lots of ways to take a snapshot. And the beauty of how our backups work and that they're streaming and snapshots is when I'm in my backup window. So for this example, I've got 4 days worth of backup data going to S3 streaming. And when I go past day 4, I start trimming it off and only maintaining 4 days worth of data. If I take a snapshot in that window, it's just a pointer. So whether I took a snapshot or not, if I'm maintaining 4 days of backup retention, at any time I can do what's called a point time recovery, and I can provide a UTC timestamp. And based on that UTC timestamp, we're going to go into this backup technology and we're going to hydrate our data into a new cluster. A snapshot is basically a pointer capturing that timestamp when I'm in the window. Zero cost, right? It doesn't cost much to store a timestamp. And that's why we don't charge for a snapshot when it's in the backup window. Over time, that snapshot gets older and older. So for snapshot 2, let's say we're doing this process every 3 days. Snapshot 2 at some point goes beyond that 4th day. And our backup streaming is trimming everything beyond that 4th day. So as that snapshot pointer approaches the end of what we're streaming, we need to make what you would consider a full copy of your data for that point in time. So it kind of goes off the end of the backup window here. A full copy gets created, meaning you're now going to be paying S3 storage rates for the size of the data required to reconstitute your server as of that snapshot pointer, right? So some customers have SLAs where they need a snapshot once a week for a month, and then they once a month for a quarter, and then once a year for a year, right? So what they're doing is creating these time snapshots and then eventually starting to delete them to not incur additional cost on there. So when I learned that how snapshots worked in the window, I was really excited because it's a great idea.
Yeah.
And the challenge is, like, when I tip over the end, now I'm, if I have a 30 terabyte cluster, my snapshot has gone from free, it's a pointer, to 30 terabytes of S3 storage. So pro tip, you need to keep an eye on these. They can certainly add up. Also worth noting is the backups are self-trimming. They maintain themselves. Snapshots, you manually create them and you must manually delete them. There's no,
Right.
not that I've seen yet, there's no policy where you can say, I don't want them for more than a year, and they just go away. They stay. And so you need to keep an eye on them from a cost perspective to make sure you have some kind of reporting or automation. And we have a metric for backup storage, I believe, and snapshots fall within it. So you can certainly create something in CloudWatch with an alert to make sure you're not keeping an eye on what becomes part of your bill.
Right. Yeah, and that's a very good point, right? It's very easy to take a snapshot, right? It's because there's no impact, right? No impact backups, no impact snapshots as well. So it's very easy to create these snapshots. And honestly, sometimes it can be easy to forget that they're out there. So do keep that in mind. So I just want to, I know we're a little bit past halfway, but for folks who may have joined partway through, so this is the March DocumentDB Insider Hour show, and today we're talking with Tim, or I'm talking with Tim, about DocumentDB operational capabilities. So welcome if you just joined, and with that, we'll get back to the next capability here.
Great. So Doug touched on this earlier. Read replicas, right? Your primary instance in your cluster is doing all the writes. It is certainly capable and willing to handle read traffic, queries, and aggregations, for example. But it's maintaining your data. You do an insert, it's going to make sure that collection gets that document. Any indexes on that collection get updated accordingly, and gets all that data to storage. The read replicas themselves aren't doing much, right? As part of the process, when a write goes to the primary, its job is to do it, right? You might have a unique secondary index, right? We have to guarantee you're not having a violation there. But when it goes to write to storage, it writes to storage. the moment it gets those 4 acknowledgments, it kind of, figuratively taps the read replicas on the shoulder and says, "Hey, by the way, this just changed." Like it's giving them notification. The important part of the notification is if the read replicas are interested in what just happened on the primary. So say, and by interested, I mean the data they had in memory is now changed because of an insert or an update or delete. They have to immediately address that and keep that latency, the lag of the replication, as low as possible. So that's done over the network via these notifications. If for some reason the inserts going into the primary have nothing to do with what's going on in the read replica, so you're inserting into collection A and all the reads you've done ever are collection B, these notifications are uninteresting. So it just drops them on the floor. And if a query ever hits the read replica for collection A, it just gets that data from the storage volume, right? So it's kind of got this two-way to do it, right? If it's in memory, I need to replace it with the updated information.
Mm-hmm.
If it's not, I'll get it from disk later, when and if I ever need it, because I might not ever need it.
Right.
There's no point in keeping the read replicas up to date with the primary for collections and indexes that they're not doing anything with. The cool feature, as Doug mentioned earlier, about using this shared storage plane is what it means that the time to add additional read replicas is constant. We quote 8 to 10 minutes. I've seen it slightly less, but that's kind of where you want to think about it from a workload perspective. But it means if you've got an application that, afternoons, it's something, youth related, you get a lot of traffic on your site from 3 to 5. You can certainly add 2 additional read replicas at 2:45. They'll be ready by 3. Use them for 2 hours at 5 o'clock. Take them out of your cluster. That 8 to 10 minutes is constant. If your cluster has one 10 gig chunk in storage, or we can store 128 tebibytes. Let's say you have a 100 tebibyte cluster. You can add the read replica in 8 minutes. Doesn't matter how big the data is, and that's pretty unique, right? Most systems, the read replicas have their own storage, and they're doing the same work the primary is doing for writes. They could be simplified, like a wildcard update on the primary might be a little harder than a secondary, because you're kind of figuring out the primary keys and reducing the footprint of the work, but it's still quite a bit of work. And what that creates, I like to say, is read replicas, they're mostly idle, or let's say bored under most workloads, because they're just waiting for queries and aggregations to come their way. They're not updating indexes and inserting data. So you can expect about 95% of availability. So they might be at 5% CPU.
Mm-hmm.
And if you have your, the other interesting thing you might find is your primary, because it's doing all the writes, is organizing data that it cares about in memory for write traffic. Whereas by these readers being read-only, you get more out of your cache because you're not dealing with anything that's not being requested, right? A lot of workloads are, writing one thing and reading another, and they can be separated. The last important thing to keep in mind is it takes time, right? So when a write is durable on the primary, it's, say 20 to 100 milliseconds of time it takes to get those notifications processed by the read replicas. So we encourage customers to use read replicas, but make sure your queries are tolerant of that eventual consistency, or the replication lag that it takes to get there. Most workloads are.
Yep.
If you need to read your own writes, if you need perfect, everything that's been done is available to my query, then those queries need to go to the primary.
All right. Yeah, and that is that is the, I'll say, the default and the best practice. Right? You spin up a DocumentDB cluster and use the connection strings that we provide. Right? That's what will happen. Right? All of your updates will go to the primary. All of the reads will go to any replica instances that you have in the cluster. But even on an operation by operation basis, right, you can override and say, well, for this particular read, I need that one to go to the primary. Right? And maybe the other 99%, they can go to the replicas.
Mm-hmm. Agreed.
Yep.
So we talked about high availability earlier. Global clusters is about, I would say the most important thing about global clusters is disaster recovery. So DocDB is a regional service, instance-based. So when you start your cluster, you're in a region in 3 AZs. You might have an application requirement that you need to survive should the if an AZ goes down, you're okay. That's high availability. But what if the whole region is down for some reason? You want your application to keep going, right? Global clusters allows you to select up to 5 secondary regions. So you have a cluster in US East 1, and you want to put another cluster in US East 2 in Ohio, for example. Right in the console, CDK, CLI, you can add a global cluster, a remote cluster to your region, to your existing region. The data is going to seed pretty quickly. It's very storage optimized. And once that cluster is up and running, the replica lag, we talked about lag in region to 10 millis, 20 milliseconds to 100. The replication lag to remote regions, typically less than a second. It's going to depend, right, how far away they are and how much traffic is being processed in the primary region. And then for recovery, you can do it in less than a minute. This replication is going to be done at the storage level. So similar to backups, the cluster itself is unaffected performance-wise. It doesn't know what's going on under the covers, nor does it care. This remote region is read-only, so not just for disaster recovery purposes, but if you have an application and you want to localize your reads, you might want to have your primary region in the US East 1 in Virginia and a remote region in Japan, for example. Rather than queries for local customers, folks that are in Japan, you could run those queries locally. The writes still have to come back to the primary region, but the reads can be done locally. But what it's going to provide, again, back in the day when I was doing this, if you told me my systems could have a recovery point objective of 1 second and a return to operations of 1 minute, I would have told you there's no way possible. Right? I wasn't getting anywhere near that. The last thing to keep in mind is this is manual, right? There aren't systems in place. Unlike failover locally, we handle that for you. You, as a customer, have to decide if you want to make a remote region writable, right? Because some customers might want to wait, give it 10 minutes to see if everything comes back to normal. I want to stay in US East 1. But you do have to go in if you want to make the remote region writable, and it's an operation. You detach, and then you can start writing to that remote region. But if you left the existing region writable and writes were happening there, you've got a little bit of divergence. So you need to be careful. Should it come time to failing over.
Yeah, this is a good point about the operation there, and like I said, it's going to be different for every customer, and even potentially different from application to application that you may have. You've got different requirements. The other thing, just to tie on to the read scaling, right, on a prior slide, that if you do look at this, say for like a local read use case, like here you see app 2 can connect directly to Tokyo, right? Maybe the APAC customers can connect to that cluster for lower latency reads. Right? So just the way you can scale out a single instance to 15 replicas, if you scale the secondary regions and each of those secondary regions out to the maximum, right, you can have 90 global replica instances, all with data, in with a less than a second replica lag between them. So huge read scale.
Exactly. This is a brand new feature that I like a lot. And the reason is this. Let's say you want to customize synchronization of data that's going into DocumentDB to a remote system. That remote system could be relational. It could be a NoSQL database. It could be an accounting system, right? There's all kinds of interesting integration you can perform. So DocumentDB, since version 3.6, the first version, has always had a concept of a change stream. And a change stream is capturing inserts, updates, and deletes. And we can do that at the collection level, at the database level, at the instance level. Like every single collection could hit this change stream. Prior to this feature, we have technology called the Database Migration Service, DMS. It can source from DocumentDB change streams and push data to external systems, but it's very meant for like to like. It doesn't allow. It's not built for us to have a lot of customization. Remapping, masking fields, pulling fields out of documents. So what customers would do is you'd create a Lambda, and that Lambda would connect to your DocDB change stream. using a token that it stored somewhere, and it would get changes from this stream. And then at some point decide either there's no more changes or I've done 5 minutes worth of processing. I need to go to sleep. So then it had to take that resume token and put it somewhere. I would always encourage customers, keep the token in the DocDB cluster you're using for the change stream, because if you can't get the token out of DocDB, it means there's an issue and it's down, and therefore there is no change stream, right? Like some
Yeah.
customers look at me like, I don't want to put it in one place. Well, it makes sense to me, but you could put the resume token in Dynamo or another DocDB or in the file system or in S3. Like there's all kinds of options. And then you need an event bridge to fire to make your Lambda run, right? So you had all these extra moving parts, and the Lambda had to connect to DocDB, give it the token, get some data, do stuff with the data. Like there was a whole bunch of boilerplate that would be deployed for this. This feature makes it real easy. Like you can create a Lambda and tell it to source off of a DocDB chain stream. And the Lambda gets very simple. The Lambda doesn't need Event Bridge to be run. It doesn't need a place to tuck away a resume token that you never want to lose. Like you'd almost have to triple check that you're writing it correctly. What happens in this Lambda is the changes get pushed at it, right? So you're getting the change stream automatically when there's data to be dealt with. And you just focus on your business, right? It's kind of what we tell you to do with everything else. Let us do the undifferentiated heavy lifting because we know infrastructure. Go write your app for your customer, for your line of business. I liken that to this, where it's like, just go in and focus. If you're a Python shop, write a Python Lambda that just deals with a insert, update, or a delete that occurred on a collection, and then do whatever you want to any external system you want to get it to. So I'm excited that this feature is here. And I've talked to lots of customers in the past, the old way that I'm going to now communicate the new way to, and hopefully convince them to be kind of changing how they've deployed.
Yeah, I mean, this is, and if this was the February show, right, we wouldn't be talking about this. Yes, I mean, this is brand new, just went GA late last month. But like Tim says, if you've already been working with change streams and reading those lambdas, right, there is a fair amount of work and other infrastructure that's greatly simplifies that. All right, and it's I like to think of it, it's more of an event-driven approach. All right, we're just gonna call your Lambda that you've got deployed. The other approach is it's kind of like the kids, are we there yet? Are we there yet? You're just constantly every minute, got any changes? No. Got any changes? No. Got any changes? Yes. So it's a different paradigm. So simplifies it a lot. Yeah.
Agreed.
Thanks for bringing that one in. This is an important new capability.
Sure. Well, we're down to the last two. This one's big, right? We announced this at reInvent last December. So for the longest time, DocDB, we'll call it instance-based, since there's now elastic clusters. In instance-based, as we've shown slide after slide, it's monolithic. You have a single writer and up to 15 readers in a cluster. And what that means is you can only go as fast as our tallest server. So if you're running on a 4XL and you need more write throughput, you can upgrade to an 8XL or a 12 or a 16 up to a 24 on Intel and 16 on Graviton. But you will tap out at some point your write throughput. There's just, we don't have a 48XL yet. Someday we might, and you might be able to go faster that way. But Elastic Clusters is about write scale, right? DocDB instance-based has amazing read scale, monolithic write scale. What we brought to Elastic Clusters in this picture, as you can see, is we've got this request router, and we've implemented sharding. So in this model, right, we have 3 shards, meaning 3 clusters or 3 writers under the covers. And when you write into a sharded cluster, you decide collection, you make a determination, you decide what field you're going to shard on, and we use a hash-based algorithm in the background, and we're going to distribute your data across the existing, whatever the current size of your cluster is. So in this scenario, as long as you pick a good shard key, and that's a topic for another day, your writes are going to pretty much hit shard 1, shard 2, shard 3, and be well distributed between the 3. What does this mean to end users, right? On the highest end instance types, like a Graviton 16XL or an Intel 24XL, do a lot of performance testing. You can certainly get up to or over 100,000, let's say, inserts per second on a collection with an average doc size of a kilobyte and a secondary index or 2. These are known quantifiable numbers, and your cluster can only be 128 tebibytes. Your collection can only be 32 tebibytes large. By going to elastic clusters, you can multiply.
Yeah.
And it's not linear, right? A 2-shard cluster is not 2x a 1-shard cluster. Scaling in general tends to be, 1 to 2, you get some improvement. Once you get to 3, you start to kind of hit your stride, and then you can go higher than that. We support 32 shards today, so you can easily get over 1 million writes per second on a workload that is shardable, right?
Yeah.
Like you're going to have to find a way, something in your collection that allows you somewhat of an even distribution of data. Because if you shard on customer ID and you only have one customer, then you're sending every single insert, update, or delete on that collection to the same place. But
Yeah.
um, very interesting. Definitely similar to DocDB. We're trying to take all the complexity out of the process, right? If you're using Elastic clusters, you tell us a collection is sharded, you pick your shard key, and then you just get to work. And if you want to, grow and shrink, that's the other interesting story here, right? We talked about cloning a while back. Cloning with sharding is amazing if you're doubling your cluster. So if I have a 2-shard cluster and I want to go to 4, let's say I had shards A and B, and now I have A, B, C, D, right? A clones to C, B clones to D. So we're making a data copy in the blink of an eye because we're basically going to use cloning under the covers. So, doubling your cluster, 20 minutes to double a cluster, regardless of data size, because we can clone.
Very
If
cool.
you're going non-power of 2, we have to copy the data, right? There's just no way around it. So we'll clone for some of it, and then we copy the rest to try to go fast. Doug just reminded me, so we will end on time. We've got one slide to go here. I didn't want to leave out performance troubleshooting. I'm being a little selfish here. I get on a lot of customer calls working on performance troubleshooting, but 2 things to keep in mind here, tools to have in your back pocket. We have performance insights, and we have the profiler. And I look at them, they're complementary and very different at the same time. For performance insights, that's going to help you understand where the time is going on an operation. So CPU, IO, latching, what types of, what do we see going on in these operations? It's focused on something called average active sessions. So it really favors operations happening concurrently versus something that there's one execution of and it ran for an hour, right? That's a different problem to solve. So I look at Perf Insights as, why do I like it? Great UI, turn it on and off dynamically. No server restarts ever. It'll keep 7 days of data, no charge. So why not? Just use it anyway. But again, it's kind of at that, it really wants to see things that are running concurrently, the same query running 5 at a time. The profiler is the complementary feature that's been there forever. PI came out, Perf Insights last year. Profiling we've always had. So for the profiler, the pros are, it's there to catch long-running operations, the query that took a long time or the update that took a long time. Totally user-defined. You turn it on and off manually. How many milliseconds do you consider a slow operation, et cetera. The one challenge to it is it might require a server restart. So you have to, in your cluster, you have to tell it that you want to push profiling to CloudWatch logs. And in a non-default parameter group, you have to turn it on and pick your parameters. So I encourage all customers, turn the profile on day one, set the minimum high if you're worried about getting too much data in your logs, but get it turned on, because you can always change the milliseconds that it gets tripped by, 50, 100, 1 second, 10 seconds. You can't turn on CloudWatch log pushing dynamically. So if you wait till you need it, you might end up with a maintenance window.
Yeah, no, that's a very good point about profiler. I see. I'm sorry, I forgot your dog's name, but I think they agree.
Trisket was telling me it's noon. He's like, "Hey, we've hit the 1 hour mark."
We've hit the 1 hour mark, and we have. So Trisket is a good timekeeper. So thank you, Tim. This has been great. Thanks for running through in no particular order, 10 operational capabilities. And I want to thank everyone for taking time out of their day to join us here this month. We'll be back again in April with another topic. Until then, take care, and we will see you all again soon.